Here we're going to explore a method for finding roots of functions, and we're going to assume that we don't actually have a computer do this for us. Now, it might seem a little bit strange that I'm actually going to demonstrate this on a computer, but it is useful to know, partly because this is actually how computers will calculate roots of certain functions. Okay, so we're going to allow the computer to do certain calculations for us, but we're going to kind of stop it from doing other calculations, pretending that the computer doesn't know how to find a root for us. Okay, so, and you know, this could be potentially mimicking how the computer is going to find a root for us. Okay, so I am starting with this function, x cubed minus 2x minus 5, and I'm asking how can we use some basic calculations to estimate the roots of this function f. All right, so we're going to start with any guess. And so here I have the value of f at some value x1. Okay, so this is x1 is going to be my initial guess. And f of x1 is not very close to 0. I'm looking for roots, so I'm looking for a number that's 0. The output is 0. So I'm just going to check out some other. Looks like if I go farther to the left, my output gets more negative. So I'm going to see if I can find another number another input that gets us closer to 0. Oh, looks like we're getting closer. -4, -5. So maybe there might be something going on between -4 and -5. I'm going to continue. Oh, -1. Ooh. So this is a continuous function, and f of 2 is negative and f of 3 is positive. So that means I actually have to have a root between 2 and 3. So since f of 2 is closer to 0, I'm actually going to start with my first guess is going to be 2. Okay? So f of 2 is -1. And so I can actually plot the point to -1. Why don't we do that? And I'm going to put it x1, f of x1. Okay. Okay. Pretty close. And then the thing is, what we're going to do is we're going to calculate the derivative of the function. And I'm assuming that the derivative is probably positive here because since f of 3 is positive, I'm guessing that the function goes in the positive direction at this point. So I'm going to calculate the derivative of the function, and I'm going to pretend I need to do this by hand. So f of x is x cubed minus 2x minus 5. And so let me just copy that and paste it down here so I can have it in front of me. So the derivative is 3x squared minus 2. Okay, so I'm going to ask the calculator to calculate what is f prime of 2. Okay, so the derivative is 10 at 2. So that means that whatever this graph looks like, it has a slope of 10 here. So I can think of, a line with a slope of 10, and I'm actually going to go ahead and put that line in there. Okay, so there's my line with slope 10. And what I'm going to do is I'm going to say, well, what is the 0 of this line? And I'm going to allow that point to be my new guess for my root. Okay, so I started with a guess of 2, and basically Newton's method just gives me a way of refining my guess and getting a little bit better of a guess using the derivative. So here's my next guess, which is my next guess is 2.1. And by the way, this is the calculation. that I did. So the line, that green line, was here. And so it has, the slope is f prime of x1, and then it's that slope times x minus x1 plus f of x1. And if I solve for where this equals 0, I get, this is the calculation. x2 is negative f of x1 divided by f prime of x1 plus x1. So you can take that just by solving, this stuff equals 0. And I don't really want to get into that calculations. There's going to be another video for that, but I just want to show you the idea of what's happening here. Okay, so basically now I have a new guess x2, and I'm going to do the same thing. I'm going to figure out what f of x2 is. Let me look at this. So here's my f of x2 is now 0.061. And so f of x1 was -1, and now f of x2 is 0.061, which this means, oh, we're getting closer. Like, this feels closer to being a root. So I'm going to do the same thing. I'm going to kind of plot the point of x2 comma f of x2, find the derivative of the function at that point. So I'm gonna go ahead and zoom in here. I'm gonna find the derivative of the function at that point. And then, so here's my new point, x2, f of x2. I find the derivative at that point, and I'm gonna find the 0 of that linear function in order to get a new estimate x3. Okay, and so I can zoom in here. So this is going to be a better estimate. And so there's my x3. And I can see f of x3 is going to be even closer to 0. And I'm going to do the same thing. Oops. I'm going to do the same thing with x4. I'm going to find the value of f of x3, find the slope of the line, and use that linear function to find another 0, and then x4 is going to be my new estimate based on that linear function, which is based off of the derivative. Okay, so let me just zoom back out here and see somewhere in here. There we go. Okay, so my first guess was x1 was, does it say what my first guess was x1 is 2, and f of x1 was -1. And then through using that derivative, I found a new guess, which is 2.1. And f of x2 was 0.06. So I got quite a bit closer to 0 between f of x1 and f of x2. And then I used the slope of the tangent line at x2 to get me a new estimate, x3. And then f of x3 is 1.9 times 10 to the minus 4, which means 0.00019. And then I use the derivative at x3 to find another linear function, find the 0 of that linear function. That gives me an x4. And f of x4 has 8 zeros after the decimal point, right? It's times 10 to the minus 9. So you can see, like, x4 now is actually a very good estimate. And you can also see that I am getting closer and closer to, these guesses are actually getting closer to each other. I started out at 2, then I went to 2.1, then 2.09, so it's not very far from 2.1. And then between these two, like the two numbers actually are the same up to the third decimal or the fourth decimal place. So if I wanted to say that I want to be accurate up to 4 decimal places, then this looks like the correct estimate up to 4 decimal places would be 2.0946. Okay, since I round up. So this is the idea behind Newton's method. And in the next video, you'll actually see the calculations. And you can see what the calculations were here. They're, wait a minute. This is the calculations. Anytime you have a guess, then the next guess will be the previous guess minus the value of the function at the previous guess divided by the value of the derivative at the previous guess. And that just really comes from this this calculation of the tangent line and finding the zero of that tangent line.